Warm greetings. Welcome for online video session on software testing, module 4, first chapter. Myself Jagadish, Associate Professor, Department of Computer Science and Engineering, Canara Engineering College, Bangalore. So in that last class, we saw the definition of the software testing, then the verification and validation and distinct goals of software testing process. Then we saw about the inspection and testing. So what are the advantages of software inspection over testing? We saw. Then next we saw the model of the software testing process, and then we saw the development testing. In the development testing, we saw the 3 levels of granularity, unit testing, component testing, and so system testing. In that we saw the first one, that is unit testing. What are the importance and what are the automated test as the 3 parts in the unit test we saw. So next, choosing unit test cases we will see in this video session. So unit test effectiveness. What is the unit test effectiveness in the software testing? The test cases should show that when used as expected, the component that are testing does what it is supposed to do. The components that you are testing does what it is supposed to do. So you are testing the component and what actually it has to supposed to do, you should know. That is, you should know means that the test team should know that what the component used for development of a software has to do, produces output. Because to develop a software, we make use of number of components. Number of components are being used to design software. So each component has to be tested separately. That is unit test. And we should supposed to know what output has to be produced when the component has been tested. If there are defects in the component, so if there are defects in the component, they should be revealed by the test cases. If there are defects in the component, they should be revealed by the test cases. So whenever you develop a component for the software application, when testing the software component, you should design a test cases. So test cases in the sense the how it reacts for the data which is not a actual data, there is some other data that is actually not what is required for the component. So you have to design a test cases. So if you find any defect in the component, then the test cases has to reveal the error in the component. So this leads to 2 types of unit test cases. So this leads to 2 types of unit test cases. So what are that? The first of these should reflect a normal operation of a program and should show that component work as expected. So one is the first of this should reflect normal operation of a program and should show the component work as expected. So as far as the software engineer, so what output has to come of that particular component has to be expected in the unit test cases. The other kind of test case should be based on testing experiences of where common problem arises. It should use an abnormal input to check that these are properly processed and do not crash the component. So abnormally input, in the sense other than the actual input, has to be given to check the component in such a way that whenever you give the input, it should not crash. The component should not crash in such a way that you should process the abnormal input to check the components in the software application. So this is the unit test effectiveness. Testing strategy, though partition testing as well as in the partition testing, where you identify the group of inputs that have common characteristic and should be processed in the same way. You should identify the group of inputs that have a common characteristic, something like how we categorize the first class distinction student, then average, above average, something. We should characterize the input of the same components or some other components that is being used in the application, and you should choose a test from within each of this group. And guidelines based testing, where you use testing guidelines to choose the test cases. So you choose the test cases as well as testing guidelines for the test cases. These guidelines reflects the previous experience of the kinds of error that programmer often make when developing a component. So you have developed a components and the components have been tested using a test cases. Then you find defects in the components. Then you send back the components to the previous, that is to defect the remove the errors. Then that experience will make the programmer or there is a test engineers to check the components once again with the help of the previous experience. So that errors or defect has been removed or not. So that is what the guidelines says. It reflects the previous experiences of the kinds of error that programmer often make when developing a components. So partition testing, this is what input data and output results often fall into two different classes. So input data and output results. So once you give input, the output results will be often fall into two different classes, where all members of the classes are related. Each of these classes is an equivalence partition or domain where the program behaves in an equivalent way for each class members. Test cases should be chosen from each partitions. So you define a component where each component have a number of classes. So in that there is each of these classes is a equivalence partition. Will partition the component to a number of classes because number of classes are used to define the components and where the program behaves in a equivalence way for each class members. So test cases should be designed for the each partition of the component. So you can see the possible inputs and correct outputs. There is possible outputs. You have a input, that is a component. In the component you have divided the subcomponents or classes into equivalence partition. So input equivalence partition, these are all partition the classes. And when you test the output of this input, so there it produces a possible outputs. So this is what the actual correct output, and this is what the actually partition, and this is actually the possible output. But in that the correct output you have to check, and if they find any errors in the component, then you have to redesign you should give a summary of the problem or the errors, defects found in the components to the previous session or previous one who developed this component to rectify the defects. So this is what actually how we are going to divide the component into equal partitions, so that software tester, testing engineer can design the test cases efficiently way, and they can find the defects easily, and they can send the defects components to the previous one who developed. So by that finding the defects in the components, they can rectify it. So that will be helpful for the software test engineers to see the there is errors in the next testing cases, so whether it is been removed or not. So equivalent partition, they are given one example here. Number of input values. So number of input values. So less than 4 means you get a till 3, from 0 to 3. So between 4 and 10 means you will be getting 4 to 10. So more than 10 means from 10 to the one here output, the result from 11 to till 10, it gives the partition the data. So in the previous session, how we have partitioned the input, this is how they given an example. So you have a number of number from 1 to something some number. So how you going to partition? So the number which lies because you have so many datas. For example, if you can consider the Aadhaar card itself, where it contains a 12 digits number. So I'm telling you just an example, 12 digit number. So you are placing the number from 1 to 3 has to be lie in between in this group, and from 4 to that is 10, it has to be between in this session or partition, and above 11 it has to fall in this number. Of course, other number will be falling only in these two partition only. So some other number which is having something more number or where some numbers will be having something like 4 digits or 5 digits numbers. I'm telling when you took the other example, it will be like between these two partition. So less than 10,000 is till 999 it falls in this session, and between 10,000 to that is 1 lakh, it will be fallen in this session, and more than 10 lakh it will fall. Sorry, from 1 lakh to more it fallen into in this partition. So this is what an example they have given to better understand of the how the input will be partitioned to check the component. So it will how the test cases are being designed to check the components. So test guidelines, test software with sequences which have only a single value. So test software with sequences which have only a single value. Use the sequences of different sizes in different tests. Sequences of different sizes. So some sequences will have a 4 digits, some sequences will have a 5, some sequences will have a 6. So depending upon that, define the test cases or in different tests, and derive the tests so that the first, middle and last element of sequences are assessed. Test with sequence of 0 length. So these are the guidelines has to be followed whenever you are designing the or testing the cases. General testing guidelines, choose an input that forces the system to generate all error messages. So here whenever you test any components or in an application, it is always better you should find as much as possible error messages. So such a way that you should design a test cases. So something is a test case is something like a filter. You should have a number of filters to test the defects in the application. Design an input that causes the input buffers to overflow. Repeat the same input or a series of input numerous times. So sometimes when you test the components by giving some input, at that time you may get a wrong output due to some test cases or due to some wrong input. So it's always better to test the cases, test the components one more than one time. So you come to know whether that components have a defect or not. Force invalid outputs to be generated. Force invalid output to be generated, and force computations results to be too large or too small. So this is what we saw in the development testing. In the development testing, we saw the choosing a unit test cases, and we saw the equivalence test, how the components will be divided into number of components, the sub components, and we saw one examples on the equivalence of the tests. And the next we go on for the component testing. So in the component testing, so what we did is a unit testing. So we did that is dividing the component into sub components to test the application. So you will have a find errors easily, and you can rectify it. Now it is testing whole components. Software components are often composite components that are made up of several objects, several interacting objects. So for example, in the weather station system, the reconfiguration components includes objects that deal with each aspects of the reconfiguration. Excuse me. For example, in the weather station system, the reconfiguration components includes objects that deals with each aspects of the reconfiguration. You access the functionality of objects through the defined component interfaces. So to access the objects of different components, there should be interfaces from one component to the other component, so that we can access the object easily. Testing a composite components should therefore focus us on showing that the component interface behaves according to its specification. So you have a number of components, composite component to test the components, and you have an interfaces to access the objects from one component to another. So you should test the components along with the object. So because if you find any defects in the first components, then if not able to find a defect in the first component, then that a problem will be arises in the second component, because it will be that object will be accessed by the other component with the help of the interfaces. So that should not be happen. You can assume that the unit testing on individual objects within the components have been completed. Obviously, you have completed a unit test of components. So you didn't find any error in that unit test. It's not that you are not able to get a error in the or defect in the as a whole component. You will be finding, but you should filter. You should have it write the test cases in other way, not how you wrote the test cases for the component for unit testing. So you can see the interface testing diagram. You have a test cases. You have a number of components, and you can see the A as well as B as well as C as a main that is component. You have a main component where you can to work these three main components. You have a number of sub components are supported. So we don't know the object may be accessed by or which is declared in the subcomponents can be accessed by all other components of the main components. So you have to test the cases in such a way that you should get a proper output. So it should not defect because you can see here A is dependent on B, B is dependent on C, and C is dependent both on A and B. So it is not that when you correct this main component, the A component, it's or if you find any defect in this component, if you not check properly in the subcomponents, then that input will be given to this component, or maybe this component, or maybe this to this component. So if you didn't found a proper error, then there will be a problem for all the main components. So because are all interacting or interconnected to because they access the objects from one component to the other component. So the test engineer has to take care test cases efficiently, and have to design test cases such a way that what are the defects you found in what are the defects missed in the unit testing, that should not be happen in the component testing. And interface testing, objects are to be detected false due to the interface errors or invalid assumption about the interfaces. Interfaces types. So what are the interfaces types? Parameter interfaces, shared memory interfaces, procedural interfaces, message passing interfaces. They can ask in the examination, what are the different types of interface errors are in component testing? One is parameter interface, shared memory interface, procedural interface, and message passing interface. In the parameter interfaces are interfaces in which data or references are passed from one component to the another. So parameter interfaces, data passed from one component to the other component, or one method to the other procedural to another method. So always if you find a error in the one component, that is one interfaces, if you not detect the error, then that parameter interfaces, because most of the data are or objects, whatever that is used in the one component may be input to the other component. So if you not find a proper error in the component, that these are the problems will be happen in the component testing. So parameter interfaces, these are the interfaces in which data or some times a function. There are sometimes functions, references are passed from one component to another. So in this methods and objects have a parameter interfaces. Second one is a shared memory interfaces, and in this a block of memory is shared between the functions. Block of memory. So the memory which is used by the object, it is being shared by the some other interfaces also, because some other component. So this is because if you didn't find there is error in that object, then it misleads to the problem in the other component also, because they share the memory. So these are the interfaces in which a block of memory is shared between the component, and data is placed in the memory by one subsystem, maybe or retrieved from there by other subsystem. This type of interfaces is often used in the embedded system example. Okay, so you should take care in this also. And procedural interfaces, and these are the interfaces in which one component encapsulates a set of procedures that can be called by the other components. So procedural subsystem encapsulates a set of procedures to be called by the other subsystem. Message passing interfaces, these are the interfaces in which one component requests a services from another components by passing a messages to it. So message passing interfaces. These are the different types of errors, interfaces error, and different types of interfaces errors that is defined in the component testing. Along with this, these errors fall into three classes. So what we saw this are different types of errors, okay, in interfaces. So these interfaces errors will fall into three classes. So what are the three classes? One is interface misuse, interface misunderstanding, and timing errors. So that don't get confused in this interface errors, types of interface error. If they ask in the examination types of interfaces errors, these are the different types of errors. That is parameter interfaces, shared memory interfaces, procedural interfaces, and message passing interfaces. If they ask what are the classes that error fall into different types of classes, in that interface misuse, interface misunderstanding, and timing error. These are the different types of these are the different types of the classes that different types of error fall into these three classes. Interface misuse. Interface misuse. A calling component calls some other components and makes an error in the use of its interfaces. So instead of calling one component, it may call some other component. Then there will be problem or there will be defect in the testing. So that is that's what called the interface misuse. That is calling, instead of calling a friend A, you may call a friend C. So it will be an interface misuse, so calling some other component. This is one class. And interface misunderstanding. A calling component misunderstands the specification of the interface of the called component. A calling component misunderstands the specification of the interface. Specification of the interface means the component may want other object according to the specification. Because misunderstanding of the specification of the interface of the called component and makes an assumption about its behavior. So the called component does not have a behaves as expected by the causes. Unexpected behavior in the calling component. Something like binary search method may be called with a parameter that is in unordered array. The search would then fail. Something like this is what example. So binary search method may be called with a parameter that is unordered array. If in that unordered array, how you can search binary search? So at that time binary search get fail. So this is what example given for the interface misunderstanding and timing error. So timing error is this occurs in a real-time system that when a shared memory or message passing interfaces, there is timing error, shared memory or message passing interfaces. Something like called and the calling component operates at different speeds, and out of the data information is accessed. So something like related time errors. You people are writing examination. You have to write examination at 2 o'clock. Whereas other batch student is still writing examination in that particular hall, where you have to write examination in that particular hall at 2 o'clock. He won't leave because he keep on writing the examination. At that time, you don't have a time, there is seats to sit in that particular hall. So even though his time is get over, he keep on writing the examination. At that time, you also people suffer a lot. So this is one example, or you can take it in. That's what this is the example of something in the practical examination I spoke. Okay. So timing error. So these are the error falls into three classes. So interface testing guidelines. In interface testing guidelines, you have design the test so that parameter to be called procedures are the extreme ends of their ranges. Always test the pointer parameter with null pointer. Design a test which causes component to fail. Use a stress testing in message passing system. In shared memory system, vary the order in which components are activated. So they can ask in the examination, give a general guidelines for interface testing. So examining, that is always design a test so that parameter to be called procedure at the extreme ends. So something like examining the code to be tested and explicitly list each call to an external components. So design a set of tests in which values of the parameter to be external components are the extreme ends of the ranges. So you should have there is a log where components has to be tested and explicitly list each call. So whichever there is object has to be needed by some other component has to be, that is first come first serve. So who requests the component, who requests the object first, will be given opportunity for that particular component. So the such type of has to be taken care in the interface testing. And in the always test the pointer parameters with null pointers. So where pointers are passed across the interfaces, always test the interfaces with null pointer parameter. Third point is a design a test with a which causes the components to fail. Where component is called through the interfaces, design tests that causes the components to fail. Different failure assumptions are one of the most common is specification misunderstanding. So you are asking some other that is interfaces, that is component A, and by misunderstanding the component that is will be sent to the some other interface, there is some other component, that interface will be sent to some other component. So because of that misunderstanding, the actual component which for whom it is required interfaces won't available. So that should not be happen. So that has to be taken care in the guidelines of the interface testing. Use a stress testing in message passing system. This means that you should design a test that generates many more messages that are likely to be occur in the practices. Last is a shared memory system. There is in several component that is interacts to the shared memory system, and design the test so that order in which these components are to be activated. So in the shared memory system, since most of the components will make use of the shared memory, so here also first come first serve. So which component requires the services first has to be share the memory, the interfaces first for that particular component, and according to that it will get activated. So these are the guidelines for the interface and testing. So in the interface testing, inspection and review can sometimes more cost effective than the testing for discovering a interface error. Inspection and review can sometimes be more cost effective. There is review and inspection will be more cost effective discovering the interface error. So that will also be taken care in the interface testing. So next is the system testing. In the system testing, during development involves integrating a components to create a version of the system and the testing the integrated system. So you have a number of versions. So by adding a number of by changing a components, so you know version number also we get keep on changes. So now you have tested a unit testing, now integrated tested, as well as now whole system. You have you will be this clubbing all the components as a one together and checking the testing the that is software or application. So that creates a version of the system. The focus in the system testing is testing the interaction between the components. System testing checks the components are compatible, interact correctly, transfer the right data at the right time across their interfaces. Because you will be in the when you design a system, there is nothing but application. We have a number of components, and the components will have to interact a number of interfaces. So whether right interface, right at the right time, the interfaces will act according to that component or not will be checked in this system testing. So you have found number of interface error. Why that interface error occurs? Because the component, if it is doesn't active or behave properly, then interface errors occurs. So that should not be happen. So that is being also checked in the system testing. System testing tests the behavior of the emergent behavior of a system. So it's system testing tests So with giving a 3 stages, something like that is normal stage, high stage, and middle stages. So how it behaves in that will be something like how you keep that is a car, how they tested. If it is if a car get hit or get crashes, whether the people in the car will have a wound or will whether going to die or not will be checked, no? Something like that. If it goes at 50 kilometers and hit, how the car condition will look, and if it goes at speed of 80, how the car condition will be it will happen, and if it goes at the 100 speed, and what the car condition, also and what are the changes will be happen to the whether the driver will alive or the driver get dead, etc. That type of testing, how they test the same way software also being tested in all the conditions. So in each condition, what are the changes will be happen is will be checked in the system testing as whole system. All those things that is testing is also done in unit testing as well as component, but singly. That is a single component. Here all the components are merged together and making a system testing once again in this stage. System and component testing, and system testing also be called as a integrated testing. Okay, so system and component testing. During the system testing, reusable components that have been separately developed and off-the-shelf system may be integrated with newly developed component. The complete system is then tested. Component developed by different team members or sub-teams may be integrated at these stages. So now components have been designed by that number of teams, sub-team, like that. So all that will be tested in the unit test as well as in the integrated testing. Then here all are being integrated once. System testing is a collective rather than the individual process. In some companies, system testing may involve a separate testing team with no involvement from the designers and programmers. In some companies, system testing may involve a separate testing team with no involvement from the designers and the programmers. Obviously, some companies the test system testing will be separately, where designers or the programmers want to involve in that particular team. So what are the defects happen by them will be identified by the testing team separately. Use case testing. The use case developed to identify system interaction can be used as a basis for the system testing. Each use cases usually involves several system components. So testing the use case forces this interaction to occur. The sequence diagram associated with the use case documents that the components and interactions that are being tested. So use case testing is also being used to test the system or integrated testing. So you will come as well a sequence diagram associated with the use case documents, the components and interactions are to be tested separately. So you can see this diagram is a collects a weather data sequence chart. So weather station, that is actor, requests the report from the satellite communication. So satellite communication reports the because he requires a weather data report. So he requests to the satellite communication. The satellite communication doesn't have a weather data, so he requests there is a permission to the weather station to send the weather data. So he acknowledges immediately. Then it gets it sends the data or a request for the communication link to get send a summary report. So communication link sends a acknowledgement to the weather station. Then it requests a summarized report to the weather data. Then it sends a there is acknowledgement to the communication link. Then weather station sends a report. After receiving that, it will send an acknowledgement. and it replies a report to the weather station. So weather station once it receives, it sends a acknowledgement. So this is what actually the how the weather station system collects the weather data. So this is what you have to design a test cases to collect a weather data. So testing policy, there is a exhaust system testing is impossible. So testing policy which defines the required system test coverage may be developed. Example of testing policy: all system functions that are accessible to the menu should be tested. So all the system functions that are accessible to the menus should be tested. So if you see this previous example, you consider this as only a menus that is in the front end, and each that is weather information system is accessing a data from weather data. So you send a satellite communication request. So satellite communication, once it receives there is a request from the weather station, he has to send the acknowledgement, and that is been done or not will be checked by giving a some request and whether it sends an acknowledgement. This is not that the test engineers will check for the weather data itself. Something is they send a request, whether they are getting a acknowledgement from the satellite communication. By seeing the sequence diagram, the cases or test engineers or tester team will have to design the test cases. So this is what, by anyone, if you see this here, how he easily can understand the developer can easily understand, or test engineers can easily understand the what are the things has to be designed in the test cases, or how to test the data or component or as a whole system. So by giving a sequence diagram or use case diagram, test engineers or system engineers can easily understand the system and they can design test cases. So all system functions that are accessible to the menu should be tested. Combination of the functions, that is tested format, that are accessible to the same menu must be tested. Where user input is provided, all functions must be tested with both correct and incorrect input. So you should test all the functions by giving a input that is correct input, as well as incorrect, that is wrong input also. So if you give a wrong input, what are the, whether system it crashes or whether it gives any output has to also be checked. So that is also important in the testing policy. So this is what we saw in the test system testing. And the next part is a test driven development. We'll see it in the next classes. So if you have any doubt, you can ask in the online section. Thank you all.